Hi, everyone. My name is Jimmy Whitaker. I'm the chief scientist at Pachyderm, and today we're going to talk about rethinking machine learning development, a data-centric approach. So first, before we start, we're going to go through our agenda for today. So our agenda today is pretty simple. We're first going to start with a quick discussion about where AI is today, and then we're going to move towards, and also the move towards data-centric AI. So in particular, how data is part of the new source code and some of the things that means with regards to how we're actually doing development. So then after that, we're going to keep it pretty simple. We're just going to move straight to some practical steps and mainly some principles on which to approach our machine learning goals and what that actually means for how we're developing our machine learning systems. So with that, let's get started. So let's start with what AI looks like today. So if we look at AI today and machine learning, we're still pretty much in the early stages. I know a lot of times when we look at research and the developments that are happening and things like DALL-E 2 and all these kinds of things, we see some really compelling initiatives and some compelling results as well. But if we look at where we are today, kind of across the industry, we're still very much in the early stages. In general, we're seeing a lot of AI growth and development across many industries, but the level to which people have fully adopted machine learning as a core principle and discipline is still relatively few. But what we do know is that those who have worked to incorporate machine learning and AI are seeing success. And from a business perspective, from a few different reports that I've read, the companies that are actually achieving some amount of success with these early initiatives are increasing their budgets. And larger companies are even turning towards AI to overcome some of the operational hurdles with, say, for instance, right now with the economic downturn, looking towards AI to actually improve a lot of these kind of operational efficiencies and even how to do their work better. So AI is kind of prime for the striking, and a lot of these organizations are specifically focusing on the next steps in their AI journey, which is where data-centric AI becomes a huge part of this situation and this process. So when we look at where we are today, people have usually experienced some amount of success, or in particular industries have achieved some amount of success with their AI journey. And they're looking at increasing their budgets for two things, really: increasing their data and improving their data, and also increasing their processes and productivity. So one of these areas that differs slightly is with deep learning, which is usually used for addressing more complex problems, where according to a McKinsey study, about 16% of companies have gone beyond the piloting phase with deep learning. But we very much expect to see this increase quite a bit here in the near future. I think a lot of people are really just still trying to figure out the deep learning processes and how to make that data work really well, which also comes to data-centric AI. So overall, personally, I see this as a really positive sign. People are seeing success with AI. Adoption is steadily increasing. And even though we're in this early adopter phase, it really seems like we've made it past this chasm that's usually referred to in the technology adoption life cycle. This chasm is usually, if we don't get enough early adopters, then a lot of times the adoption of a particular technology can completely fall off. But it really is starting to look like we've made it past this early adopter phase and moving into these early majorities where AI is completely mainstream. So with this, let's talk about what is data-centric AI. So with these trends and even budget allocations in mind, we start to understand the reason for the shift to data-centric AI. But first, let's talk about what data-centric AI is. So you've probably been exposed to the concept before. You've likely seen one of these types of diagrams. I have three here. And ultimately, they're really all saying the same thing. Data-centric AI is centering and focusing your development on the data rather than the modeling techniques. And basically, it's we're trying to add information to our model, or trying to get our model to learn new things and relevant things by iterating on the data to provide these improvements, rather than trying to just iterate on the model and leave our data stagnant. And really, this makes a lot of sense. But what are the reasons for this shift? So the main reason for the shift to data-centric AI is, in any scientific endeavor, you really have to isolate the variables to understand the effects of your change. For instance, in academia, the techniques are being compared to each other. People are usually iterating on the machine learning algorithm or how we're training batch normalization, all these different things to get models to converge quicker and better in the deep learning realm, at least. And to understand the effects of these changes, you have to be able to compare things. So in academia, for techniques to be able to be compared to each other, the data set is usually the simplest and most common thing to isolate. data can contain just a myriad of variables, and so it makes sense to isolate it. But in practice, data is the key to the whole problem, and ultimately it's the output that matters. So whatever is going to get us the best results ends up winning. This is where we want to spend the most amount of effort if we're actually trying to produce something that's going to be usable. And this is where specifically data-centric AI has been huge. It means basically if we iterate on the data, it's going to get us further. Now, this doesn't mean that we can completely ignore models and hyperparameters and everything as a starting point. We still have to have a reasonable starting point. Once we have something, though, we start to see that these gains and improvements for iterating on the model are diminishing returns. And so that's when we focus more on the data. Because ultimately, machine learning is 100% dependent on the data that we give it. The whole purpose of machine learning is to use data to learn patterns and even just repeated items or just repeated patterns and just things that exist in our data, the structure, there we go, the structure of our data. And we're learning that from the data. So if we don't have data that we understand and we know is going to impart knowledge to our model, then it's pretty useless to iterate without iterating on that data. So another reason is we usually understand the data as humans more, but we don't always understand what our models are going to learn from it. So we can label data, we can iterate on that data, and this is going to provide better insights to our models. And then ultimately, all these things really come together. So we still need a reasonable starting point. Machine learning is dependent on this data. And these gains that we're going to see by iterating on one or more of these variables really is a trade-off. But ultimately, we're seeing that the diminishing returns from state-of-the-art models, there's very little difference between one state-of-the-art technique from another state-of-the-art technique as far as the ability to learn. So there's this relatively little difference means that iterating on the thing that's going to provide the most value is probably worth more of our time. And we're seeing this across quite a few industries, in particular with speech recognition and computer vision and even NLP and those kinds of things. So we kind of went through the intro relatively quickly, talked about the high overview of AI and where we are, and then also talked about what data-centric AI is. But when it comes to the practical steps for doing data-centric AI, this is usually where things get a little bit more interesting. People tend to usually try to provide one tool or say this tool is the right thing for everything. This is the all-in-one. But really, unfortunately, with data and machine learning, every problem is different. We can't really do a one-size-fits-all. So instead, what I would like to do is I want to focus on a series of principles and some of my own experiences and talk about some of the guidelines or some of the things that you want to keep in mind as you're iterating. Because frankly, a computer vision problem is going to be treated a little bit differently from a speech recognition problem or a NLP problem or even some structured data issues. So, but what we should keep in mind is that there are a lot of principles that are going to be general across all of these industries. And so keeping these in mind and not trying to find this one size that fits all, these guiding principles can go a lot further. So before we start talking about these principles themselves, I want to give you a little bit of information about my background because it's going to help with some of the examples that I give. So before working at Pachyderm, I actually was working at a company called Digital Reasoning, but we were working on building speech recognition models and NLP models for the financial industry. And the reason that I want to bring this up is that we were using some of the really early stage speech recognition frameworks that were fully deep learning based, character-based models. And the difficulty that we consistently ran into was adding different languages or different accents or all these different things that came together to recognize speech or be able to transcribe speech inside of a financial context. And so we really had to make a shift to data-centric AI very early. And we basically made a lot of the mistakes and learned a lot of things along the way. And so a lot of these principles come from my own experience in working on those things. So the first principle that I can't emphasize enough, and that's why it's number one, is to set yourself up for iteration. If you're using machine learning to solve a problem, then it's probably no simple problem. You shouldn't expect to be able to solve it all in one fell swoop. You're going to learn a lot about the problem in every small success, and probably even more, you're going to learn about the failures. And this is really the lesson in agile development and software. you rarely, or if ever, will take a Hail Mary strategy where you try to build this whole product and launch it and don't expect to touch it anymore. And it's going to be just a complete touchdown. Instead, what we usually do is we split development into sequences of repeated cycles. So the whole idea is we want to get something out the door that's working with the real world and then refine it based on feedback from customers. This is the whole story of DevOps, which is a really important concept to grasp, especially when you're working on like the coding side or the modeling side. But the biggest difference comes in when we're actually looking at data and data-centric approaches. The best or the most important thing to recognize is that there's two development loops that we're now working with. We have the coding loop. So this is kind of the DevOps lifecycle that we're used to going through. But we also have this new data loop, this data lifecycle that's also just there. Like we're having to constantly incorporate the lifecycle of our data, the iterations on our data sets into our modeling approaches. And not only this, there's a symbiotic relationship between these two things. So the biggest difference when it comes to a data-centric approach inside machine learning is that there are two development loops, the code and the data, and they're both crucial. Now, the data lifecycle is a topic of many talks that I give, so I won't repeat too much of it here. But the key is that it must be treated with just as much care as your code. For instance, if there are, just like there can be bugs in your code, there can also be bugs in your data. And it's really important to be able to fix those bugs in some steady fashion. If your data set's frozen and you can't ever make changes to it, or if you make changes and they're wrong and you can't go back, you're going to be in a real world of hurt. So structuring yourself for iteration from the ground up, both your code as well as your data, is a key component for, and it really leads to everything being easier in the long run. So everything that you can do to set yourself up for iteration when you're working on your code, as well as when you're working on your data, is going to pay huge dividends in the long run. And the story around this, at least when we first started working on voice surveillance for financial companies, we were early on in curating data sets. We were a group of engineers. We were focused on solving the problems quickly. We were hoping we could, this will sound silly in today's context, we were thinking we could solve some of the, say, English transcription pretty quickly, get something out because state-of-the-art everything with deep learning, and then move on to the next problem. So we were young, we were a little ambitious, but the data was kind of a new thing to handle. We were using these character-based models, which means that each step of the transcription process was outputting a character, A, B, C, D, E, F, G, for example. And using this character-based approach, we had a couple of different data sources that we were scraping from the internet and combining together. And the important thing there is that digits weren't actually a part of our original character-based transcription. So what this meant was in our scraped transcripts, we would see someone had put, in this case, the 2008 result for Q4 in like the financial context. Converting that to numbers would be the 2000 spelled out 8 results for Q4. But the problem was we didn't really think about setting ourselves up for iteration on this. We thought, oh, we're going to get this data, we're going to convert it, and then we're just going to train our transcription model on this. And it's going to be that simple. But the real problem came into play when we started actually seeing the results of these transcriptions when we were applying it to real world data. What we had found that there were multiple ways someone could say 2008. It could be 2008, 2008, 2008, or 08. All of these were relevant ways that people may have spoken this digit. So there's a many to one mapping, and getting that right from a conversion standpoint. That would then later on be the data that our model would learn on was becoming a huge problem. And so we had to actually do some pretty heavy going back and like actually apply some human effort to label that in retrospect. But yeah, what we found is that our model would learn it. It would learn to turn 2008, even if somebody said 08, it would know it had learned to convert 08, the spoken text, into 2008. So the machine learning models can learn pretty much, especially deep learning models, can learn anything you give them, even if there are artifacts in your data. And so setting ourselves up for iterating on our data and even iterating on the pipelines that converted our data from a raw source to a curated data set was a huge lesson that we learned. And we set ourselves up for that later on, that we always want to be able to have a repeatable way to go from a raw data set to a converted data set, and knowing that we're probably going to have to iterate because there's always going to be nuances to the data. So the next principle that I want to provide, or that I want to talk about, is that great tools help make great products. So just like we talked about a second ago, converting this data from a speech and transcript source to a curated data set is no easy task, and we have to set ourselves up for iteration. Iteration is really the key to a lot of these things. But the more time that you spend debugging your tooling rather than actually working with it, it makes things a lot more difficult. I'm sure everyone's had to deal with that, where they've constantly spent time trying to figure out why the tool isn't doing what we thought it was actually going to. And choosing the right tool for the right job is a crucial component as well. So this principle is really to spend the time to choose your tools correctly and think about where you're going to go, both with an iteration perspective and also with what things are you going to be working on most commonly. Because every line of code that you end up writing as a workaround for your tooling is going to end up becoming a hurdle. So we see this pretty commonly in software development. Like, the reason that we're so fast and we're able to move so quickly is because of tools like our like GitHub, very obviously, like Docker, like Git. All of these things, and even CI/CD frameworks, come together to make our software development much, much easier. But if we're spending a lot of time debugging our testing framework or anything like that, then we're spending less time on our development itself. Now, there's always going to be some overhead here, but overall, spending time figuring out the great tools and the great products that are going to make your life much easier in the long run is a really crucial thing to do. So for me, at least my story in this is how I actually originally discovered Pachyderm, was trying to work through how do we iterate on data and keep our release data sets up to date. So for me, myself, I was originally just a research engineer, and then I was a manager of the research engineering group, and then that grew to director, and I was heading up a few different teams kind of inside of the research, the R&D efforts, I guess, but also the applied research inside of the company that I was at. So as our R&D group began to grow, both in responsibilities as well as the number of people, I needed to focus more on how the pieces fit together, both between groups logistically and also practically. So we ended up forming these different groups. We had our data strategy team that would acquire, curate, and release data sets. And their primary focus was iterating and improving our data, and also serving the customers, which were usually research engineers and data scientists, most typically. We had our data science team that was taking techniques and then applying them to customer use cases. So they were consumers of the data strategy team, but also consumers of the research engineers, who were the ones that were developing the techniques. So they were the ones working on, should we do character-based models? Should we do character engram-based models? Or like, what types of techniques are going to be most amenable to tuning inside of a customer environment, et cetera, et cetera. So for me, at least, when I was overseeing these different groups, the hardest thing was to figure out what was the delivery mechanism and how should these groups interact together. And this is where I first, like I said, discovered Pachyderm, or came across Pachyderm, which, if you don't know, and that's actually why I guess I moved to Pachyderm later on. But basically, the main component was we needed a way to version our data in a scalable way and also be able to iterate on that data. And we'll see from a principle coming up that being able to iterate on that data, both from an iteration perspective, but also from just a logistics perspective on who's iterating on that data, is very, very important. So just coordinating your data and coordinating your releases and everything on a single platform is really crucial. Just the ability to make sure that you have the right tools to keep everyone in sync is going to save you a lot of time and effort. And we're actually seeing a lot of this inside of just the community today. So for instance, this is actually from a post inside of the AI Infrastructure Alliance on kind of the evolution of the canonical stack. And what we're seeing is that people are focusing on, for instance, like Pachyderm or Tekton or Selden. These groups are focusing on what they're really good at, and also realizing that there are going to be gaps. Choosing the right tool for the job doesn't mean there's an all-in-one tool. And in fact, I think like trying to build an all-in-one tool is usually a little bit fraught with errors or some difficulty. But we're seeing some of these tooling choices, or these companies coming together to build the right stack that solves a lot of problems. So And these things can be plug and play, and in some cases, and how they fit together is really interesting. But it's really exciting to see this move towards kind of a canonical stack, or trying to figure out where people work the best and how they should interact together. So the third principle, we want to make it easy to write, test, run, and reproduce our analytics. And this may sound like a very, very big, huge, encompassing principle. But really, reproducibility and simplicity are the key to being successful inside of really any software endeavor, but even more so in machine learning. Now, this has been a common theme throughout software development, like the Linux philosophies of making analytics to do one thing well, make sure that things can be tested, et cetera. But where this really starts to intersect or interact with machine learning itself is with data pipelines and how we're packaging things up and how these components are interacting together. So this cartoon right here really talks about how data pipelines can be very finicky, and a lot of times they're going to be very fragile. And this is due to not having a standard way to package up your software and not thinking about how it's going to be packaged up or shared. And developing disciplines on this front is supremely important. So for example, I'm a huge fan of Docker for packaging things up, because I used to use a lot of deep learning libraries, which had system dependencies. And usually if you're going to end up scaling up or doing distributed processing in some way, either on your data or even like when you're training your models, you're probably going to end up deploying that on Kubernetes. And so having a containerization step inside of your process of packaging things up to make sure that A, your code is reproducible, B, that it can actually be run on other people's systems, and C, that it can actually be distributed across a cluster. The packaging things up in a consistent way is key in this regard. Now, we talked about the code, and that's a pretty standard thing, but what about when our data meets our code? And so a lot of times people think about reproducible experiments as data, or like the version data, the version code, and then the version hyperparameters or whatever else is being used to tweak that code and how it's applied to that data. And this is another area where I became a huge fan of Pachyderm before joining, is how they treated this. And so basically, inside Pachyderm, there's some data repositories and then data pipelines that you can connect to these data repositories. And why this is interesting is that you can iterate on your code, and ultimately it's packaged up into a Docker container. And then these containers can be essentially watching in a pub/sub fashion data repository. So as I change my data, I'll always have an updated and fully ready to go data set. So in my case, if I have my data curation team working on some new data set, they could continually be iterating while my research engineers were iterating on their techniques to see if they applied to this new data set. You also always have the version, so they could be working off of version 1 while my data strategy team was working on version 2, et cetera, et cetera. So this was a huge component of why we were looking at Pachyderm, using Pachyderm in various areas, and why I became a big fan myself, because keeping these data and code components together, and then also having lineage of all the artifacts that were produced from these changes was supremely important, especially when something went wrong. You always hope that nothing goes wrong, but when it does, you need it, and there's no way out. The next principle is we want to solve one problem at a time. And the reason that this is important is it kind of follows this Unix philosophy, again, of make each program do one thing well. If we try to abstract too early, either in our code or even curating our data, we're never going to end up solving the problem at hand. And if we're trying to solve some future problem while trying to solve the problem at hand all at the same time, I know I've seen this in code where we end up having an idea of something that we want to implement in the future, and we build full class hierarchies for something that we end up never getting to, and it increases the complexity of the code. It reduces the maintainability of the code, and also we probably have a better idea of how to implement that once we're actually working on the feature. So in this regard, we definitely want to focus on solving one problem at a time. Now, in data, e.g. object detection in this example, I've commonly seen people try to add too many classes too soon. So when we're building an image recognition model or an object detection, or even something that's more salient like image segmentation, which is a very difficult labeling problem, I've frequently seen people try to add too many classes too soon. And with a large variety of objects, labeling becomes very tiresome. If you've ever labeled data, you know this to be true, and even more error prone. So for instance, if I start with a small set of classes, label them and know these classes really well, say 4 or 5 different tasks, I can go through these images relatively quickly. My eyes know what to look for and everything else. But if I get to the point where I have, I think like 60, 70 classes here, then I get really tired. I start looking at these images and thinking, oh, okay, what other, traffic light. I forgot that that was one that I needed to label. And so I end up trying to solve for that traffic light, but I may have missed that in previous images and have to go back. And you just have only so much bandwidth in your brain of what you can actually label. And reducing the problem space to something that's really simple that can be iterated on, and then add a new set of classes and a new set of classes is a much, much better way to get from the original task and then label them and actually have a lot happier group of data labelers, but also a happier time labeling it and higher quality as well. Ultimately, we want to iterate towards this more fine-grained functionality. Because ultimately, things don't always stack linearly. Like, for instance, when we were working on our audio analytics, we got to the point where we were doing more and more analytics. We weren't just doing speech recognition anymore. We were building things like speech activity detection to figure out when people were actually talking, speaker change detection, when there was dialogue, et cetera. And we made this mistake. We tried to have our labelers label all these things at once because we thought, oh, if they're already looking at this audio file, why not have them label everything before they move on to the next file? But humans aren't computers. So not only did this drastically reduce the efficiency of labeling, sometimes I remember I saw over 40 minutes of effort to label a 2-minute audio clip, but also lower quality across all of the tasks. We even had fewer people committing to labeling the tasks, and all the more moving parts that we had across the board, it just made all of our quality lower. So we ended up reducing the number of things that we'd ask someone to focus on labeling and get more labelers to do these smaller, simpler tasks, and things were much, much happier. So I highly recommend keep this overall principle in mind, solve one problem at a time. The fifth one that we want to talk about is quality. So quality is usually what everyone actually cares about within the organization. And quality is an everyone problem, including the data quality. This is usually a little bit of a touchy subject because sometimes in organizations, people will try to shift the responsibility of quality or try to figure out who's to blame if something's not up to snuff. And ultimately, this is kind of a general communication and transparency pattern that needs to be developed inside the organization. We want to be able to communicate and work transparently and describe how we're going to solve our tasks, and also think about the different issues that could creep in between groups, especially, but also remember that we're all on the same team. So for instance, if you notice an issue with your data, like for instance, your organization may look something like this. If you notice an issue with your data, or even with your code, then you sort of want to be able to set yourself up to fix it. This kind of goes back to the iteration speed and setting yourself up for iteration as well, specifically with your data. If we think about like our code, we never really set up our code to never be improved upon or only by a certain group. Usually, if we have our code on GitHub, it's open for anyone to see because we know if someone sees a bug, they can contribute a pull request to improve it. And so we also want to set ourselves up on the iteration front with our data to be able to be improved as well. But the concern here is that sometimes you're going to notice something that's going on with your data. If you're a data scientist or a research engineer, or even one of the business leaders, if you notice an issue with the data, just reporting that issue is one way to do it, but it's going to be a lot slower process to getting to where you want to be. Instead, you want to share this quality, not only of how you're approaching the problem, but also with how you're iterating on things. If you can just fix the data and have it be done, and if you have the right tooling in place to allow you to not completely host someone else's work from a reproducibility perspective, then this goes, because this kind of goes back to tooling, then this can be a huge, huge win. For instance, and don't get me wrong, you still need this PR review process. You have you want to review the process with which someone labeled some data because it might be incorrect, and you need tooling that supports this. But submitting a change or a fix to data labels should be something that you try to enable across the team and get people to share the quality of the work. Because I've realized as well, if you've ever spent any time labeling some data, then you start to come up with a lot of ideas of how you can do that problem better. Because ultimately, yes, this is a shared responsibility to keep quality high. So don't work transparently. Talk about the things that you're working on, describe how you're going to solve the tasks, and iterate towards that common end together. And see the overlap between groups. So let's recap. So we started with a conversation about why data-centric AI is so important. And really, the main reason for this is that iterating on data is going to get us further. And so during this process of iterating towards making our machine learning models applicable to the context that we're trying to deploy them in production, that is, in the real world, we can't really have a one-size-fits-all for these AI problems. We're probably trying to solve some very unique problems inside our own industries. And so because there's no one-size-fits-all, there are some practical things that we can learn. So I kind of shared 5 of my principles that I think are the most useful principles in approaching AI, or specifically what to think about that maybe you're not thinking about already. And the first one is setting yourself up for iteration. With all of these problems, we're not going to solve them the first time. There's going to be bugs in our code. There's going to be bugs in our data. And the more you set yourself up for iteration and think about how your team can iterate on these different things, the better you're going to be. The second one was that great tools help make great products. If, as you're thinking about iteration, you want to grab tools and purchase tools and pull things from open source, there's an amazing set of tools out there. They're going to come together to make great products. But the more time that you spend on getting that tooling right and getting the right things in place, the easier your life is going to be in the long run. The third thing is to make it easy to write, test, run, and reproduce your analytics. Now, this goes everything from data pipelines all the way to how you're putting models into production, and even how you're just sharing models or notebooks across your organization. These are all really important, and making it easy to run these things and write these things is going to set yourself up for iteration. It's going to make life a lot easier in the long run. And so we talked a little bit about Docker and Kubernetes. And some of these are some newer tools to maybe some data scientists and everything, but don't underestimate the power and how useful they can be, because it's a lot worse trying to set up someone else's environment on your computer when you don't really know what that environment is. The fourth one was solve one problem at a time. So don't go to trying to solve or like boil the ocean all at once. Don't label 50 different classes all at once. Or have your data labelers label 50 classes all at once. You're going to get low quality, both on the labels. People aren't going to be interested in doing the labeling tasks. Iterate and solve one problem at a time. If you can even apply a machine learning model and do some active learning, that's even a nice way to do things. But solve one problem at a time. Keep things simple. And lastly, quality is everyone's problem, including the data. And so this one is a huge thing. It kind of goes across all of this. Your tooling has quality associated with it. Your coding practices and even the way you're curating data. Quality is a shared initiative across everything. And so it's supremely important to keep that in mind. Don't think yourself too good to label some data. Don't think yourself too good to dig into the code and figure out why something does something you didn't expect it to, because any iterations towards making something a little bit better is going to increase the quality of life for everyone. So with that, I just want to thank everyone for listening, and check out Pachyderm and book a private demo if you're interested. Reach out to me on Twitter or read some of my things on Medium about the data life cycle and those kinds of things. And it was a pleasure. Thanks so much.